Welcome to Solar Engineering Service Module 3. Today we will learn how to size PV streams correctly using temperature limits, invert voltage windows, and real-world design rules. At -15 Celsius, each module's voltage rises. 27 modules stay below the 1500 watt limit. It is safe. If add just one more and the stream voltage exceeds the limit, it fails. That's why engineers always size for the coldest day. A PV stream is a set of modules connected in series. Voltage adds up while current stays constant. Stream sizing must satisfy invert voltage limits, MPPT range, temperature extremes, voltage drop, and module mismatch. Utility scale modules typically operate at 40 to 50 watts and 12 to 18 amps with power ratings between 500 and 650 watts. We calculate open circuit voltage at cold temperature using the module's temperature coefficient. This ensures the stream level exceeds inverter limits. For a module with 49 watt open circuit voltage and a coefficient of -0.28% per degree, open circuit voltage rises to about 54.5 watts at -15 Celsius. This diagram shows how open circuit voltage increases when the temperature drops. At STC, the module sets around 49 watt, but at -15 it rises to 54.5. This cold temperature voltage is what we use for stream sizing to make sure we don't exceed the inverter's maximum DC voltage. We calculate open circuit voltage at cold temperature using the module's temperature coefficient. This ensures the stream level exceeds inverter limits. Dividing 1500 watts by 54.5 watts gives a maximum of 27 modules per stream. Oversize streams using the worst case cold temperature. This ensures safe operation year-round. Once the stream is sized, the next step is choosing the right cable. In Module 3, we learned how PV streams behave and why temperature plays such a critical role in stream sizing. Cold weather increases module voltage, so we always calculate the worst case open circuit voltage at the lowest site temperature. That value determines the maximum number of modules we can safely place in a stream without exceeding the inverter's DC limit. We also check the MPPT voltage window to make sure the stream operates correctly throughout the year. The key takeaway is simple. Stream sizing always starts with the coldest temperature. In the next module, we will move from voltage to conductors. I will show you how to size solar DC cables properly, including MPPT, voltage drop, insulation rating, and practical field considerations. This is where electrical design becomes real-world engineering. If you are enjoying this solar engineering series, feel free to like the video, subscribe to the channel, and share it with everyone who might find it helpful. It really supports the channel and helps me keep producing engineering content like this. Thanks for watching Module 3 of the Solar Engineering series. I hope this helped you understand how to size PV streams with confidence. I will see you in the next video, where we can continue building your solar engineering foundation. Take care and see you soon.